Let us study some terminologies. For example, this one peak sun hour. It is a daily radiation and referred to as a common as PSH, full radiation. Okay, it is the number of sun rays for the day it is falling on a particular area to get the rated 1 kilowatt hour per meter square. This it is known as a peak sun hour. Next is irradiation, the total quantity of radiant solar energy per unit area received over a given period. For example, for daily 24 hours or per monthly or annually, the amount of radiation which is received a particular area where the site where the PV panel they are going to install, it is called irradiation. Insolation is the amount of solar radiation incident surface area for a period of time. Okay, so this is another one there. Irradiance, the solar radiation incident on the surface, particularly if it irradiance means the solar radiation which comes at the surface of the earth is called as irradiance. In this one, first if you see this particular graph, if you see this graph, it shows the peak hour of the sun. It is nothing but a peak hour of the sun. From 7, it is measured from morning 7 to the evening 5:30. Particularly during the time of 10 to 2 hours, the radiance or radiation of the sun will be more. The effect of the earth atmosphere on the solar radiation. What happens? See, when a solar radiates electromagnetic waves, that time what happens? Most of the energy never reaches the earth. 30% of the radiation is reflected into back to the space. So when it enters, it is having 1367 watt per meter square energy radiance. That is, when it reaches the surface of the, it becomes from 1300 to 1000. It becomes the reason for this one. It is there are many reasons why such things happen. The first reason is it is reflected by the atmosphere, the outer atmosphere of the earth. It reflects back the most of the radiation. Then inside the earth inner surface, inside the layer, inside the earth layer, particular layer, atmospheric layer, there are clouds are there. That clouds also reflects the radiation, and when the radiation reaches the surface of the earth, earth's surface also reflects the sunlight. So nearly 30% of the rays get reflected. And if you see particular at the north hemisphere and the south hemisphere, the amount of energy most more amount of energy is reflected. And at the ocean, particular at the ocean, the sun rays are absorbed. Let us study some of the terminologies. In this direct radiation, the radiation which directly passes to the earth's surface is called as a direct radiation. Diffuse radiation, there are many clouds, gases inside the atmosphere in the atmosphere of the earth. So most of them are either the sun rays or radiation, either it is getting reflected or it is absorbed. That is called as a diffuse radiation. Air mass, that is the distance that radiation must travel through the atmosphere to reach the point of surface. So that is distance from travel from the outer layer to the surface of the earth. It is called as a earth mass. Now we will go to this particular diagram. If you see diagram carefully, you can see the sun is emitting the rays, and from the rays at the one particularly, it is getting reflected from the outer surface of the earth. Some of the getting reflected inside, dust particle, gases, clouds are there. They either reflect or they absorb, and nearly some amount of energy or radiation it is getting absorbed in the earth's surface. This, if you see, this is another one diagram which shows the clear sky as well as the cloudy sky. In the cloudy sky, you will be unable to find the radiation. Either it reflects or it absorbs. Whereas in the clear skies, more radiations are clearly visible and reaches the Earth's surface. This is particular from the Earth surface of the Earth, air mass, and it is directly related to the altitude of the sun. Whereas if you see in the equator area, the radiation is comes directly, and if other altitude the area differs, it differs and changes, and some of the areas when it is far from the Earth, that time the radiation less amount of radiation will reaches the Earth. If you see the isolation means amount of energy absorbed particular time at or particular at the year. From one year, if you take it from January to December, the amount of radiation particularly absorbed at different location. If you compare the Australian desert and German city, it is at the northern hemisphere where the amount of sun energy absorbed or it is absorbed is very less. But whereas if you see the Australia, there's a lot of energy or sun radiation, it is absorbed particularly at that point. So now let us compare. We will compare the three cities. These are the three cities. If you see this one are the three cities. These are the three cities. The first one Nairobi, Melbourne, and Poland. We are comparing during the month of January, February, whereas the Poland receives very less amount of energy compared to the Nairobi, that is Kenya, which is in the which is in Africa, and it is very nearer to the equator, where the radiation will be more. Whereas the Melbourne is nearer, it is also receiving good amount of energy compared to the Poland. Solar radiation data, it is obtained by many agencies. For example, NASA also provides the solar energy. European Commission Joint Research Center is there, which provides the free tool photovoltaic geographic information of the system. So depend upon the different area, the energy is absorbed or energy is transmitted by the sun. Now we will compare the average daily electric production. It is between Paris and Dakar. Dakar it is in the Morocco. Morocco it is in Morocco, that is in Africa, and whereas the Paris it is in the northern hemisphere. So if we compare the electricity produced by the African country and Paris, the Dakar it is getting more, it produces more electricity through the sunlight compared to Paris. But in some of the months, for example May, June, July, it is almost nearly the same, they are going to produce the same electricity.